Human Factors Mission to Mars by Noble Sullivan. In order to protect the manned mission to Mars from radiation, it will require sufficient lightweight radiation shielding, biomedical advances in cancer research, and astronaut training in catastrophic radiation event or shielding failure. Cosmic radiation has a variety of effects on astronauts, including carcinogenesis, which is the catalyst for every form of cancer. Radiation can also cause brain damage and central nervous system issues. The primary source of cosmic radiation is galactic cosmic rays, or GCRs. These kind of rays sweep the entire universe over anywhere not protected by a strong electromagnetic field or artificial radiation shielding. Some sources of this cosmic radiation are supernovas, black hole jets, and pulsars, and over a 180-day travel time to and again from Mars, an astronaut will experience the current career limit of 1 sievert. SEPs, or solar energetic particles, are very dangerous protons that have been accelerated by the sun, usually in the form of flares and coronal mass ejections. SEPs pose one of the most sudden, violent, and dangerous threats to any kind of interplanetary travel. Measuring radioactivity in space. Currently, NASA's Lunar Reconnaissance Orbiter, or LRO, is measuring radiation in orbit around the Moon. Of course, the Moon does not have an electromagnetic field, so it is an ideal place to record background cosmic radiation. For some pre-launch countermeasures to radiation, NASA may want to consider including a medical specialist trained in radiology, or perhaps even a radiologist, to handle any kind of medical situation that can arise from radiation. Also, training the crew in radioactivity drills or for reading Geiger counters can increase their preparedness for radiation's effects. Some currently FDA-approved drugs for mitigating the effects of radiation include potassium iodide, Prussian blue, DTPA, and Neupogen. Also, to mitigate radiation, heavy radiation shielding, which would likely not, unfortunately, be feasible for use over the entire vehicle, could be used in the crew sleeping quarters. This could drastically reduce their exposure level, since this is where the crew spends most of their time. Also, that kind of room could be used for emergency radiation contingencies. It could be used as a critical radiation level panic room. This would be ideal for protecting the crew from a coronal mass ejection or any kind of other major cosmic radiation event. Health checks and mitigating the effects of cosmic radiation. That same onboard radiologist could take regular readings of radioactivity and check crew members for early symptoms of radiation-related illnesses. Some ideas for materials of radiation shielding. Hydrogen-rich plastics, liquid hydrogen, wastewater, and electromagnetic fields powered by superconductors will make good radiation shields. Currently, Martian rovers use a device called a RAD, or Radiation Assessment Detector, to detect radiation on the surface of Mars. Radiation is substantially less than the levels in space, of course, but are still more than the Earth's due to Mars' thin atmosphere and weak magnetic field. Martian radiology. Radiation exposure on the Martian surface is on average 0.6 millisieverts per day, of course compared to 1 whole sievert for our career lifetime received over the trip to Mars. Of course, that can depend on solar activity levels during that part of the year or in the solar activity cycle. Any kind of Mars shelter would require extra shielding outside of the main craft in order to protect astronauts from Martian radioactivity. EVAs outside of the craft and possible Mars shelters should be limited per individual on a schedule for each member, approved and reviewed by a radiologist or medical specialist. Radiation shielding for the future. Future manned missions may see new lightweight materials for radiation or full-fledged electromagnetic fields generating by charging the surface of the craft's hull, or perhaps projected by a device or extraneous equipment such as a electromagnetic field generator applied to the surface or outside of the craft. This has been Human Factors, Radiation and its Effects on a Likely Manned Mission to Mars. Thank you for watching. This has been Noble Sublet, and goodbye.